let's learn to multiply. multiply. And the best way I think to do anything is just to actually do some examples and then talk through the examples and try to figure out what they mean. So my first example, I have 2 times 3. By now, you probably know what 2 plus 3 is. 2 plus 3. That's equal to 5. And if you need a bit of a review, you could think of if I had 2, I don't know, 2 magenta, that's this color, cherries, and I wanted to add to it 3 blueberries, how many total pieces of fruit do I now have? And you'd say, oh, 1, 2, 3, 4, 5. Or likewise, if I had our number line, and if, let me see, and you probably don't need this review, but it never hurts. Never hurts to reinforce the concept. And if this is 0, 1, 2, 3, 4, 5, if you're sitting 2 to the right of 0, and in general, when we go positive, we go to the right. And if you were to add 3 to it, you would move 3 spaces to the right. So if I said, you know, if I just moved over 3 to the right, where do I end up? 1, 2, 3. I end up at 5. So either way, you understand that 2 plus 3 is equal to 5. So what is 2 times 3? An easy way to think about multiplication or timesing something is it's just a simple way of doing addition over and over again. So what this means is, and it's a little tricky, you're not going to add 2 to 3. You're going to add, and there's actually 2 ways to think about it. You're going to add 2 to itself 3 times. And what does that mean? Well, it means you're going to say 2 plus 2 plus 2. Now, where did the 3 go? Well, how many 2's do we have here? Let's see, this is a 1, 2. I have 2 2's. I have 3 2's. I'm counting the numbers here the same way that I counted blueberries up here. I had 1, 2, 3 blueberries. I have 1, 2, 3 2's. So this 3 tells me how many 2's I'm going to have. So what's 2 times 3? Well, I took 2 and I added it to itself 3 times. So 2 plus 2 is 4. 4 plus 2 is equal to 6. Now, that's only one way to think about it. The other way we could have thought about this is we could have said, instead of having 2 added to itself 3 times, we could have added 3 to itself 2 times. And I know it's maybe becoming a little bit confusing, but the more practice you do, it'll make a little sense. So this statement up here, and let me rewrite it, 2 times 3. It could also be rewritten as 3 2 times. So 3 plus 3. And once again, you're like, where did this 2 go? Where did, I had 2 times 3, and whenever you do addition, you see I have 2, I don't know what these, well, I said cherries, but they could be raspberries or anything. And then I had 2 things, I had 3 things, and the 2 and the 3 never disappear, and I add them together, I get 5. But here, I'm saying that 2 times 3 is the same thing as 3 plus 3. Where did the 2 go? 2, in this case, in this scenario, is telling me how many times I'm going to add 3 to itself. But what's interesting is, regardless of which way I interpret 2 times 3, I can interpret it as 2 plus 2 plus 2, or adding 2 to itself 3 times. I can interpret it that way. Or I can interpret it as adding 3 to itself 2 times. But notice, I get the same answer. What's 3 plus 3? That is also equal to 6. And this is probably the first time in mathematics you'll encounter something very neat. That sometimes, regardless of the path you take, as long as you take a correct path, you get the same answer. So 2 people can kind of visualize it. As long as they're visualizing it correctly, 2 different problems, but they come up with the same solution. And so you're probably saying, Sal, when is this multiplication thing even useful? And this is where it's useful. Sometimes it simplifies counting. So let's say I have let's stick with our fruit analogy. An analogy is just when you kind of use something as an, well, I won't go too much into it, but our fruit example, let's say I had lemons. Let me draw a bunch of lemons. So that I'll draw them in rows of 3. So I have 1, 2, 3. Well, I'm not going to count them because that'll give our answer away. Just drawing a bunch of lemons. Now, you could, if I said, you tell me how many lemons there are here, and if I did that, you would proceed to just count all of the lemons, and it wouldn't take you too long to say that, oh, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lemons. So I already gave you the answer. We know that there are 12 lemons there. But there's an easier way and a faster way to count the number of lemons. Notice, how many lemons are in each row? And a row is kind of the side-to-side lemons. I think you know what a row is. I don't want to talk down to you. So how many lemons are there in a row? Well, there are 3 lemons in a row. And now let me ask you another question. How many rows are there? How many rows? Well, this was one row. Then this is the second row. This is the third row. And this is the fourth row. So an easy way to count it is I say I have 3 lemons per row, and I have 4 of them. So let's say I have 3 lemons per row. And I hope I'm not confusing you, but I think you'll enjoy this. And then I have 4 rows. So I have 4 times 3 lemons. 4 times 3 lemons. And that should be equal to the number of lemons I have, 12. And just to make that gel with what I just did with the addition, let's think about this. 4 times 3, literally, when you actually say out the word 4 times 3, I visualize this. I visualize 4 times 3. So 3, 4 times. 3 plus 3 plus 3. And if we did that, we get 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. And we learned in up here, at this part of the video, we learned that this same multiplication could also be interpreted as 3 times 4. You can switch the order. And this is one of the useful and interesting, actually, kind of properties of multiplication. But this could also be written as 4 3 times. 4 plus 4 plus 4. You add 4 to itself 3 times. 4 plus 4 is 8. 8 plus 4 is 12. And in the U.S., we always say 4 times 3. But I've met people, and a lot of people in my family, they kind of learned in the I guess you could call it the English system, and they'll often call this 4 3s or 3 4s. And that in some ways is a lot more intuitive. It's not intuitive the first time you hear it, but they'll write this multiplication problem, or they'll say this multiplication problem, and they'll say, what are 4 3s? And when they say 4 3s, they're literally saying, what are 4 3s? So this is 1 3, 2 3s, 3 3s, 4 3s. So what are 4 3s when you add them up? It's 12. And you could also say, what are 3 4s? So let me write this down. This is, let me do it in a different color. That is 4 3s. I mean, literally, that's 4 3s. If I told you to say, write down 4 3s and add them up, that's what that is. And that is 4 times 3, or 3 4 times. And this is, let me do that in a different color. That is 3 3 4s. And it could also be written as 3 times 4. And they all equal 12. And now you're probably saying, OK, this is nice. It's a cute little trick, Sal, that you've taught me. But it took you less time to count these lemons than to do this problem. And well, first of all, that's only right now because you're new to multiplication. But what you'll find is there are times, and there are actually many times, and I don't want to use the word times too much in a video on multiplication, where each row of lemons, instead of having 3, maybe they have 100 lemons. And maybe there's 100 rows. And then it would take you forever to count all the lemons, and that's where multiplication comes really useful. Although we're not going to learn right now how to multiply 100 times 100. Now, the one thing that I want to get you, and this is kind of a trick. I remember my sister, just to try to show how much smarter she was than me when I was in kindergarten and she was in 3rd grade, she would say, Sal, what is 3 times 1? And I would say, because my brain would say, oh, that's like 3 plus 1. And I would say 3 plus 1 is equal to 4. And so I'd say, oh, 3 times 1, that must be 4 as well. And she'd say, no, silly, it's 3. And I was like, how can that be? How can how can the 3 times some other number still be the same number? And think about what this means. You could view this as 3 ones. And what are 3 ones? That's 1 1 plus another 1 plus another 1. And that's equal to 3. Or you could view this as 3 one time. So what's 3 one time? It's almost silly how easy it is. It's just 3. That's 1 3. You could write this as 1 3. 1 3. And that's why anything times 1, or 1 times anything, is that anything. So in 3 times 1 is 3. 1 times 3 is 3. And I could say 100 times 1 is equal to 100. I could say that 1 times 39 is equal to 39. And I think you're familiar with numbers this large by now. So that's interesting. Now, there's one other really interesting thing about multiplication, and that's when you multiply by 0. And I'll start with the analogy, or the example of when you add. 3 plus 0, you've hopefully learned, is 3. Because I'm adding nothing to the 3. If I have 3 apples and I give you 0 more apples, you still have 3 apples. But what is 3? And maybe I'm just fixated on the number 3 a little bit too much. Well, let me switch. What is 4 times 0? Well, this is saying 0 4 times. So what's 0 plus 0 plus 0 plus 0? Well, that's 0, right? I have nothing plus nothing plus nothing plus nothing. So I get nothing. Another way to think of it, I could say 4 0 times. So how do I write 4 0 times? Well, I just don't write anything, right? Because if I write anything, if I write 1 4, then I don't have no 4s. I'm talking. This is saying. So this is 4. Let me write this. This is 4 zeros. But I could also write 0 4s. And what are 0 4s? Well, I'll just write a big blank here. There, I wrote it. There are no 4s here. So it's just a big blank. And that's another fun thing. So anything times 0 is 0. I could write a huge number. 5,493,692 times 0. What does that equal? That equals 0. And by the way, what's this number times 1? Well, it's that number again. And what's 0 times, 17? Once again, that is 0. Anyway, I think I've talked for long enough. See you in the next video.